Alright, so today we're going to be talking about linear equations and solving equations with variables. One variable. Can somebody tell me what variable means? Okay, Mara.
It is a letter to take the place of an unknown number.
Okay, a letter to take a place of an unknown number. Anybody else? Can they explain in more detail, or they feel like Amari might not have necessarily the best answer or could add to it?
I think it's like an unexisting number that you're going to find out later.
Okay, so it's unknown. Unknown. Does the variable have to be a certain letter?
No.
No. What if I decided to put Alvin as the variable? Is that possible?
Yeah.
Yes.
Yes. That just means we're going to end up defining what Alvin is, right?
Yeah.
Okay. So today, solving linear equations within one variable. We're looking at standard E, which is expressions and equations. You're talking about solving linear equations with one variable with a rational number and coefficients. Collect like terms. Can somebody tell me what collect like terms mean? We've done that before. Outside of Amari. Okay, Rachel.
Find like terms.
Finding like terms and putting them, when they say collect, that means we're doing what, Jay?
Put them together.
Yeah, putting them together. You know, they have to be part of the same family. Maybe different families. And then expand expressions using distributive property.
Yes,
Okay, Al?
distributive property is when, let's say, for instance, you get an outside number, and you got a parentheses, and let's say you got a 5, and then you got 4s plus 2.
Mm-hmm.
So for you to do distributive property, you'll have to do 5 times 4s and 5 times 2, which will give you 20s plus 10.
Okay. So he gave us an example. Can somebody else explain distributive property? Okay, Amari, help me out.
Distribute the property.
Okay, distribute. What does distribute mean, Jordan?
I'm going to tell you basically have like the number on the outside and distribute to every other number that's inside the parentheses.
Yes, that means that it has to have a piece of or part of the same of everything that's within the parentheses. Okay, so it's distribute out evenly among everybody, right? Okay, and then the main thing I want you to pay attention to is having one, none, or infinity solutions. Infinity. Everybody should know what infinity means.
That means forever.
Oh, forever, or
Eternity.
Non-stopping.
Eternity.
non-stopping, continuous, can't stop, counting. Can somebody tell me a number that is infinity?
1 million.
That's
No,
eight
stop, 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 stop.
No.
Think.
The number never stops.
The number never stops. It's one number specifically that we know. What? What'd you say?
Pi?
Pi.
Oh, yeah.
3.14.
Now you can know some of the numbers, but it just keeps going and going and going. Matter of fact, there's an app that you can actually type in your birthday, and guess what? You probably find your birthday within pi because it's that long. It just keeps going and going and going. Non-stop. Okay? So there is a such thing as infinity. Because some of you are like, well, infinity, I don't like you infinity times infinity.
Let's go.
We don't even really know what that number is. Okay, so today your essential questions are, these are 4 questions that you must end up getting past and mastering or having some type of understanding. When are equations true? Can you give me a value of x that makes the equation true? Can you give me a value of x to make the equation false, which that should be pretty easy. And then how many different values of x make the equation true? Okay, so x, keep that in mind that it is unknown. All right? So I'm going to give you a quick video. Make sure that you pay close attention because you will have an opportunity to stand up and pair up to discuss about these 3 options. Infinity solution, one solution, and none.
It's the oldest extreme sport, and one of the most between the values of the 2 variables.
Okay. Pair up. Stand up and pair up. Now, your partner and you need to discuss these 3 bullets. Infinity solutions, how does it look? What is it? One solution, how does that look on the graph? What does it mean? And then one that has none, no solution, okay? So take a moment and discuss what did you notice from the video that has these 3. What information can you discuss? Go ahead, you got 2 minutes. Let's All right, give me 5. Finish your last thought. Okay, now I'm going to call on some groups and see if someone can explain to me infinity solutions. How did that look on the graph? What did your group discuss about infinity solutions? All right, let's go for Vance and Justin.
Infinity solutions was whenever they're always on like the same path.
They're on the same path, so it means that they have the same slope, yes, same points, same solutions. Okay, so infinity, they're pretty much, they said that those equations had to be what? They were equal or equivalent to one another. All right, one solution. Tommy and Dale, help me out. How did the one solution look?
When they intersect the one spot and it could only have one, I don't know how to explain it.
Okay, help me out, Tommy.
When it only intercepts on one spot and that's it, doesn't intercept
Yes.
over.
Okay, so they just have one specific spot that it intersects, and
One
it is
solution.
one solution. And that one solution fits both equations. Okay?
Yes.
And then no solution. None. Anybody can help me out with that? All right, Amari and Jody, they don't cross. They never cross. That means they never meet up. If it doesn't matter what value y'all put in that equation, they're never going to have the same. Right? Solution. So it doesn't work out. All right, y'all may sit. Thank you very much. Let's dig a little deeper. Now, I want to model what Ms. Davis wants you to do when you get into groups. Okay? Because at some point, you're going to have to justify each other's work. Now, we're all big about collaboration in here. Okay? We have to collaborate. We need each other's brains, juices is what I call it, in order for you to help one another. Because somebody has a little bit that you need and you have a little bit of what they need. And then if you put that together, we have a whole lot of what we need. So, I'm going to think this out. I want you to take a moment and look at it. I have Amy and I have Ben. Now, this is the same process Ms. Davis takes when she has to deal with arguing with either Amari. Yeah, I said it, Amari, and wants to argue, Ms. Davis, that's not right. And sometimes I'll be wrong. Or Jordan is trying to explain very nicely, that is not necessarily how you do that. Or I don't look at it that way. And it's okay, because everybody has different thinking, but the main thing is getting to the same objective, right? So, it has, Amy and Ben are trying to decide when the following equations is true. 5 minus x equals 6. They decided to compare their work. Okay? So, Amy says, this is her thought process. 5 minus x equals 6. So, x equals 6 minus 5. And it has to equal 1. So, is it true when x equals 1? Now, I know some of you are already thinking, okay, just hold your thought, hold your thought. So, Amy got some things going on, I don't know. I have to look at it a little bit more in detail. So let's see what Ben is talking about. Ben says, if you take a number away from 5, the answer will be less than 5, so it's never true. Never true. The key word, he said never. Now, I'm going to go back to Amy. Now, when I think about what Amy said, she said 5 minus x equals 6. So if x equals 6 minus 5 equals 1. I think, well, first off, if I just take and put 1 in the place of x, would I get 6?
No.
Would I get 6?
No, you.
Okay, so right there, Amy is not correct. Okay, so a negative 1?
It's negative 11. I mean, no, it's positive 11 because you can't subtract integers, so you make it a plus and then
Okay,
negative.
so she has some misinterpretations or some misconceptions of how she thought this out. Okay, so we know Amy is not right, and I can actually justify how by proofing this. And all I did was just plug in, what if I plugged in 1, does it really work out to be 6? And I think we all can see that it's not. Now I think she was on to something because she said 6 minus 5 equals 1. I think she's trying to do this family fact, like, okay, if I take and switch these around and subtract them, I would get what was missing. But actually, if this is subtraction, what should she have done? She should have done the inverse operation, which would have been addition, in order to find out what the original, or decompose this equation. Okay, then, if you take a number away from 5, the answer will be less than 5, so it's never true.
That's all.
Guess what?
Yes, I think, well, the issue is the never true.
Yeah.
You.
Yeah, it could be sometimes it works out and sometimes it doesn't. So never true is not necessarily right. Now, I want y'all to pay attention to their justification. Now, she used an example, and this person, he explained in word format, which is fine. Both are a great way of justifying, as long as you can prove it. We have already talked about that. Prove your math. If you want to prove to me it's wrong, well, let's prove it. Prove what Ms. Davis done if I'm wrong. If I'm wrong, okay, no bad, no bad. It happens. Okay? So, I want you to get ready to take a sheet of loose leaf paper, and I'm going to give you something to think about. And I want you to write down your name, and I want you to answer this question. Can you give me a value of x that makes this equation what?
False.
False. Makes it false. All right, pass that back. Okay, take a minute to do that. And you have to prove why is it false. Show the calculations that explain your answer. Now, keep in mind, you're not making it true, you're making it false. About 2 minutes. You're coming up with an equation, a value of x to make the equation false. So what will not equal? If you're done, I'm looking for your eyes. That lets me know you're done. Okay. Justin. What did you use? What is value? What is the value of x?
You could put 1 to make it false.
Okay, you can put 1. So 4 times 1 is 4, and then 4 plus 1 is 5. So that's definitely false. Troy, help me out. What did you use?
I used 1 for the first one, the second problem,
They're both wrong. Okay. Shemaya, tell me what you used. What did you plug in for x? 0. 4 times 0 plus 1
1.
equals,
Not equal to 3.
it's definitely not equal to 3. Okay, and you? Alvin?
0.
Okay,
I'm
you-
sitting up with 4. It's 4 times 4 is 16 plus 1 is 6.
You put
Yeah.
x as 0, 0 as x? Okay, so think about that. 4 times 0
You use 0.
and 0 plus 1 is,
1.
so it doesn't equal. So a lot of you probably found what, the easy false statement, right? Okay, so now the catch is, let's see if you can find what value can x be to make it true. Now, some of you are going to have a challenge. Hold on. I already know your hands up because you probably already figured it out, Tommy. I see it, Amari. But I have a little extra for you. When you get your bucket and you move into your groups, your bucket is going to tell you if you have a positive number as x value, a negative number as x value, or a fraction. And you have to tell me what number can X be to make it true? Go ahead and move into groups. Go ahead and discuss your problem. Bring your bucket around. Okay, look at yours. You definitely need to open up the paper. You have the worksheet with the problem on there. On the back, it's going to tell you it's a fraction that you have to come up with in place of X.
Negative one. Wait, the negative has to be a 3, so it would have to be a negative.
No, you're saying that the value of X has to be negative. So what would you multiply? How can you find the value of X, but it has to be a negative value? That would still equal 3.
That would make that equal negative 3.
No.
Not necessarily. So the catch is, how can
Negative 1?
a negative, listen, a negative value that will equal a positive 3 equal a negative? So that's what you're trying to find. Okay, in the back of it,
Let's look at the chart on the wall.
a positive 1 to equal a positive 3. So if I have a positive 3, and I have a positive 1 that's equal to a positive 3. So you need a negative just 4 times. If I had to plug in, let's just say I replace 4x. One value. What value does it have to be? That's negative.
How about 4? 4 times 4.
Still looking past, just ignore
negative 4. 4 times negative 4 is 0 plus the
just
positive
say it's one value. So a negative 2. So a negative 2 plus 1 is a negative 3, positive 3.
Oh my god, that's confusing me.
Now,
Wait, you know what we're
that's
doing
what
now?
makes it. What can I?
You know multiplication right here? Why don't we just divide 3 by 4?
That will, what number has to be here that's negative, that plus 1 will give a positive 3. Okay, now, Jackie, I want you to go to this, Maria, I want you to go to this, and they have,
About 0.75.
number, and see if you can assist them. Y'all do, I want y'all to go to this room, but they also have a negative 5. Guys, I'm running some extra GPT to see if they can help you with your brain hurts.
Why would you?
What? Now, this is the issue. They have 4x plus 1 equals 3. They have the same equations, but the only difference is that they have to have a negative value. So is there any solution for, or any value for x that is negative that would still give them a true statement, a true equation? So see if y'all can throw that around.
I got 3. Negative. What if it's negative 0.95? Doesn't work. Oh, never mind.
That's be negative.
Yes.
So
So is there any value of x that will give you a positive 3?
oh, that's a thing. That's
It has to be the whole value except plus 1.
try like 2 points. Okay, 2 points.
Okay, what's 4 times negative 3?
So, are you going with no negative 1 value?
But we're doing the stupid one.
I was gonna say, Tommy, really, Tommy? Okay, did y'all figure out any?
Oh, I know what it is. What if it's 1.75 negative 1.5? Take out my pencil.
Now keep in mind, this is what I want to ask you. If I just take and put one value in there, let's just ignore the 4. Okay, let's ignore the 4, ignore the x. Just let's say what value does this have to be here? Plus 1 that will give you 3. What negative value? Hear what I said? What negative value can I plug in here? I just put a negative value right here. That will give you, add 1, will give you a positive 3.
Negative. No. Yeah.
Okay, you said -2. -2 plus a positive 1 is going to give me a, okay, -1 plus a positive 1 is going to give you 0. So what value that is negative that you put here is going to give you a positive 3? Okay, -4 plus 1 is a -3. I need a positive 3. Is there any value that I can put here? It has to be negative. This is what I'm trying to understand. Is there any value? You said what? There's no value that you can put.
No solution.
Oh, you might want to write that down.
I'm a genius.
I want to make sure that you understand for people that are done, Joey. Says show the calculations that explain your answer. Make sure that you explain your answer. Word forms, examples. Did you get to justify your answer? All right, the way that you decorated. We're going to share out right quick. Now, how many of you have fractions?
Me.
Okay. So, we had 4 groups that had fractions. All right. Marvin, your group. What did you get for a fraction? Could you show us?
Our fraction was 1.5 because 1.5 times.
1/2.
Oh, 1/2.
1/2.
1/2. If you times that by 4, you're gonna get 4 over 2, and that equals 2, and 2 plus 1 equals 3.
Okay. This group, did you get the same thing? Did you get 1/2? Okay.
We wrote the, what's it called, equation, and because it's addition, we subtracted 1 on each side, and it gave us 4x equals 2, and to get x squared, so we divided each side by 4, and so we had 2 4s, which we simplified to 1.
Okay. This group, anything different?
No, we just use 1/2.
Okay. You plugged in 1/2.
Yeah, we
To
plug
get
in
your
1/2.
fraction. Now, this group decomposed, and then the other 3 groups, yes, you reconstruct actually. You constructed an equation using a solution. Okay? Now, these 2 groups had negative value. They had to find a negative value for x. Was it possible?
No.
Why? Why is it a no solution, or why couldn't they work that out?
No negative number will replace it.
You're gonna miss it, Dale, you're gonna miss it. Say it again.
No negative number will replace it.
Okay, so I asked them, if I plug in, I'm gonna wait. Justin, you finished? It's okay. You might was trying to justify. If you have 4x plus 1, what value do this number need to be? If I just take out the 4x and I just put one value here, what value do that need to be that is negative? When I add 1, that would give me 3. So, a negative 2?
No.
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 There's nothing.
Cannot.
It's gonna be a negative.
It's simply unequal.
Okay. So, there's no value I can stick here that would give me a negative value, but when I add 1 to it, it give me a positive 3.
I do not believe
No, it's not. No, it's not.
Okay. Okay, so this might be an example of a no solution. Okay. Now, when we dig a little harder in the algebra, you're gonna find out that it is possible. When we take it a little farther, yeah, because when we break down fractions and negative fractions, and we can really get down to breaking this down a little bit more. All right, you have to move out of groups. Thank you very much. I need one person to put all of the items in the bucket. You're gonna hold on to the bucket. You're gonna gonna need those flashcards. And I'm coming around to pick up the posters.
Notice it's personal, it's just the number squared and I found that number.
Number square.
Yeah, I knew, but I found it right in the long
That's not what I mean. Alright, one person in that group, hold on to that bucket, because you're gonna need those 5.
Justin, you're holding on to the bucket, right?
Alright. Okay, everybody turn their cards in. So now, we're gonna actually pick up tomorrow on the next step of this lesson. Okay, this lesson is really large, and so Ms. Davis has to split it up. So at this point, we're really gonna end on this note. Now, the reason why I keep giving you 2 different students' work is because I want you to take the opportunity to analyze their work. You gotta be able to find what went wrong, where did they go wrong, and justify their answer. Now, they might be correct, but you have to be able to justify why it's correct, Josh. You can't just say it's right. Jody, I know that's the easy thing. Ms. Davis, that's right. And then someone else is gonna tell you possibly it might not be. But I want you to justify it. Even if it's right, I want you to justify it by proofing. If it's wrong, I want you to justify why it's wrong. Okay? So, one person in your group has 5 flashcards. You want to pass that out to the people that is in your row or in your group. So the individuals that were in your group, make sure they get a flashcard. You're going to write your name on one side, and on the other side, you're going to discuss how many different values of x make the equation true. You're going to look at Cheryl's example, then you're going to look at Stacy. Okay, make sure you share on your exit ticket what process did you take? Did you decompose the equation, reconstruct the equation, substitution, or you just plug in a number to see if it works? Yes, if it's correct or not, but you have to justify it by proving it. And who do you agree with? Is it Cheryl or Stacy, or both, or neither? Now I will look at these, and we will discuss them a little bit more in detail tomorrow. Make sure we have a good understanding. Can someone share with me what does non-solution look like, or no solution looks like? Okay, come on, Cameron.
They don't intersect.
They don't intersect. Does it work in the equation? Like, can you find a value of that equation in the other to still be the same?
Yes.
Okay. For a no solution. No, not for a no solution. Because you found in yours, there was no value that we could plug in to fit, to make our equation true. It was still false. All right? Anybody can tell me one solution? Tommy?
When you have 2 lines and they cross at one intersection.
Okay. In an equation perspective, if I had 2 different equations, I will put the same number in for both, and it will stay true. The equation will be true. And then what about infinity? Infinity solution. Alvin?
Infinity solution is when the points are the same.
Okay, so the points are the same.
When they're going the same.
The lines are on top of each other. Okay, I get that. And then, what else? How else could you explain infinity solutions? Do the equation have to be exactly the same? No? But they have to be
Similar.
they have to be equal. So they can look different. It's like fractions. They can look different, but they have to be equivalent. Okay? In order for it to work. You can pass up your X and card, and we'll pick this up tomorrow. Thank you.